progress of man with technology has greatly improved the lives of humanity. However, all these things come at a cost. Humanity is now facing the consequences of their action. Due to the accumulation of greenhouse gases in the atmosphere, a change in the world's climate was observed, and an increase in the world's temperature was recorded. This is known as global warming, and it has brought both transient and permanent alterations to Earth's biological, ecological, and geological systems. To get a better grasp of this, we must first need to understand and study its effects on the environment. But how and what can we use to study its effects?
River morphology is a scientific study concerning the changes a river undergoes resulting from erosion and sedimentation processes, in which the principal elements are the dynamics of sediment transport and river flow.
The changes of global warming can be noticeable in the hydrosphere, which includes rivers. Since precipitation patterns are shifting, some regions are gaining additional water while reducing snow and rainfall in other areas, which can encourage adverse river behaviors, resulting to flooding and sediment deposition.
With the help from CREST and the USDP card, the researchers created 5 wirelessly connected devices capable of studying the effects of global warming on rivers through river morphology. The devices automate the rigorous manual data gathering process of 4 important freshwater parameters: river depth, width, rate of rise, and flow rate. Project FRIES provides these parameters using LiDAR technology, which it can transmit wirelessly through the internet or store it offline with an SD card.
Project FRIES consists of Project Waffle, Project ARMS, and the main controller. Project Waffle consists of the water level and the water flow rate encoder. The water level encoder measures the water level of freshwater bodies for extended periods of time. Its built-in accelerometer alerts the user if the device is not upright. The water flow rate encoder utilizes a Hall effect sensor and a neodymium magnet to measure the flow rate of a river. Project ARMS consists of the right arm and the left arm. The right arm measures bathymetric data by measuring the depth of various equally spaced apart points on a river, while the left arm measures the width of the river with the help of a scope. Modular and standalone. Project FRIES features a modular build to ease its transportation, as it will be deployed in rivers. Specifically, the water level encoder and the right arm can be disassembled and reassembled when needed. Additionally, all devices are capable of being a standalone device. So, if you need to measure a specific river parameter, the user may only bring the necessary FRIES device to collect data, since the devices can transmit data wirelessly or save it online.
All measurements from FRIES devices were compared with measurements from the manual data gathering method, and the results were: the water level encoder had a mean difference of plus minus 1.04 centimeters. The right arm had revealed a mean difference of plus minus 1.11 centimeters. The left arm had revealed a mean difference of plus minus 2.26 centimeters. All devices proved capable of sending their respective river parameters to the main controller. The main controller then was able to input the received data into Google Sheets. Additionally, all the devices proved capable of being a standalone device by wirelessly transmitting their data online and saving it offline.
The results of the accuracy test proved a similar margin of error to the manual method, as Project FRIES provides close to precise information in a much less tiring and time-consuming way. Through the integration of IoT into Project FRIES, the system streamlined collective data gathering and transmission. IoT in Project FRIES provides accessible river morphology data to the general public.